11.5, find measures of central tendency and dispersion. You will describe data using measures mean, median, mode, and standard deviation. Let's take a look at statistics. These are numerical values that summarize and compare sets of data. And the two most important types are measures of central tendency and measures of dispersion. We'll first take a look at measures of central tendency, which involve the words mean. And mean or average, we're going to use a symbol called X bar, and that's going to represent our mean, the sum of all of the numbers divided by how many they are. Median, which is the middle number, especially when it's in order, and the mode, which is the most frequent score. Let's take a look at this data for Office A. These are the waiting times in an office. So to find the mean, we're just going to sum all these up and divide by 9, and that answer will be 22. The median is the middle number, and since these are in order, that's going to be easy to find. That's going to be 20. And then the mode is the most frequent score, which is 24. Now let's go ahead and figure out the stats for Office B, but we're going to be using the calculator. So let's go into Stat, and we're going to go into Edit. And in List 1, I have already listed all of the waiting times right here. So now all I have to do is go into Stat and go into Calculate. And I'm going to do one variable, Statistics. And it's under List 1. So I go to Calculate, and then I enter. Now this is going to give me my mean, and my mean is 16 for Office B. And I want to know my median. Actually, the calculator will give the median, but you have to go down arrow. And here's the median, 18. And we visually can see that the mode is 18. I won't write that for you, but those are the three answers that we have here. Okay, measure of dispersion is how the statistics are spread out. And that's very important. One use is to look at the range, and that'll tell us how far apart the data is from the smallest to the largest. So this is how spread out Office A is in its data, and Office B right here. Let's take a look at representing data graphically. And one way to take a look at the data is through a histogram. And let's go to the next screen, and I will show you how to use a calculator on that. So let's go into Stat again. And under Edit, I have entered actually all these values under List 2. All of these are listed. There's 30 values. And I want to represent a histogram. So it's going to be under a stat plot, which is blue. Second, stat plot. I'm going to go in here. Make sure you turn it on. It's on. And then you're going to go to histogram. Take a look at the picture that looks like histogram. Make sure you're in the right list. This is, I want List 2. And if you don't have List 2, it's right here. List 2, you press second, and then List 2, and that'll paste it right there. Now go to Zoom, and you're going to use Zoom Stat. So I'm just going to press 9. And here is the histogram right here. So we can see how the data is spread out. Okay, your turn. And here's the answer. Another way to represent data graphically is what we call a box and whisker plot. And just like this little cartoon say, I can see the median. What's happening is this middle right here is the median, and this represents quartiles. So this represents 25% of the data. This represents 25% of the data, and so on. These are quartiles. All right, I'm going to use the next screen to show you how we do it on the calculator. All right, so I'm going to go to Stat Plot, or Stat, and inside the Edit is still, List 2 is still this data that I had here, but I just want to look at it differently. So I'm going to do Second, Stat Plot. I'm going to go Enter. I make sure it's on, but this time in the type I'm going to use the box and whiskers without outliers. So I'm going to enter that. And make sure it's under List 2 because that's where the list is. And then I'm going to do Zoom and Stat, which is 9. And so here's your box and whiskers. You can actually press Trace, and it'll immediately show you your median. And then you go to the left, and that's quartile 1, that's 3. and then over here is the lowest. So from 1 to 3 is 25% of the data. From 3 to 5 is the other 25% of the data. Quartile 3, from 5 to 7 is the other, and then the highest value is 10. Your turn. And here's the answer. Let's take a look at a very important stat, which is called standard deviation. This is much more sophisticated than the range, and statisticians use this a lot. Standard deviation, and here is the formula. This standard deviation symbol is read as sigma. So standard deviation sigma is this formula. Notice it's a lot more complicated than the mean formula. So the question is, what is the standard deviation of the waiting times for those offices? And let's go ahead and look at the first one, Office A. Remember that the mean is 22, so we want to follow this formula, which means I am going to do my numerator. I'm going to take my first data, which is 14, and I'm going to subtract the mean, which is 22, and then square it. Then I'm going to take my next data, 17 minus 22, and then square it, and then the next one. And I'm not going to write them all out. I'll just put dot, 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 and then next to the last data piece is 30 minus 22 squared plus 32 minus 22 squared. And then I'm going to divide it by the number of data pieces I have, which is 9. And this is the answer you're going to get. And so our standard deviation is 5.7. That's how spread out this data is. Now let's go ahead and use a calculator for B. Now it's actually, we've already done this. Let's see if I still have it up here. Nope. I'm going to do second stat. Now that one variable stat that I had, I'm going to run it again. And here's my mean. But what's really nice is it really gives me the standard deviation. It's right here, 4.5. So my standard deviation sigma is 4.5. Now this is going to allow me to answer the next question now. So now the answer is, remember it was 5.7 was for Office A and 4.5 is for Office B. So my answer is D. Okay, your turn. And here's the answer. I just put it in the calculator and found that answer. Okay, let's take a look at what outliers will do, what numbers that are not close to all the rest of the data will do. We're going to find the mean, median, and mode of these numbers right here. And again, I have it in my calculator. So I am going to just go over here, show you stats. And I'm running it over here to list 3. And you can see I have all my numbers here. So I'm going to do second quit. I'm going to run my one variable stat here, but this time I want it on list 3, so I'm going to have to press second here, so it changes it to list 3, and then I'm going to calculate it. Okay, and then I'm going to have my mean, and then I also have my median, mode, and range. And so what I can do is write these down. Let's see. Mean was 14. My median is, let's go ahead and look at it again. I have to just go down here. Median was 14.5. My mode, the most frequent score, looks like it's 15. And my range is, the smallest number was 11, the largest number was 17, so 17 minus 11, and that's going to be 6. Now what happens if I add another number into the data? So I add a 3. You can see 3 is much different from the other. So let's go ahead and go to stat, enter. And I'm going to go to my list 3 and I'm going to add another data piece. And I'm going to add the number 3. Enter. Okay, and then I'm going to do second quit. And I'm going to run my stats on list 3 again. I'm going to press enter. And let's see, the mean now is 13. And it looks like, oh, I didn't find the standard deviation on the previous one. I should have written that down. And here is our standard deviation, and there's our median. Okay, so that I don't have to go back, I'm really going to show you another page that shows all the numbers here. So here is my original. Let's go ahead and so this is my mean, and my new mean is 13. My old median was 14.5. My new median is 14. My mode was 15, and it still is 15. The standard deviation right here was 1.7. The standard deviation is now 3.5, which makes sense because now the data is spread out more with that number 3. So the mean is most affected by this outlier. The mode is least affected. And the outlier causes both the range and the standard deviation to change.